Well, hello. This is a rehearsal recording of a new talk I give. We'll see. I have a feeling it's going to be quite long, but we'll find out. It'll be thrilling and exciting. Well, hello. Thanks for having me here today. It's always fun to come and talk to people about, as the slide would say, better ways of developing software. I've been trying to come up with a catchier title for this presentation, but maybe you can help me with that afterwards. What this presentation goes over is basically if you were to ask yourself what are the best practices and most successful and good ways that people are writing software, thinking about software, and running it and deploying it, the whole software life cycle. And because I'm giving this to a government audience, I have some government-related things, and a lot more, much more so than I usually would. I mean, I would caution though that I have what I like to think of as the reverse Anna Karenina principle. That being that every family is screwed up in its unique way. But as I've traveled around the industry over the past 20 years, I found out that pretty much every organization is screwed up in exactly the same way. So things that apply to other large organizations and other companies doing things with software likely apply to you, and you're probably in a very similar situation. Your servers and your ideas may be snowflakes, but the way you implement them and the processes and the problems that you have are typically anything but. So just as another thing, my slides are usually pretty dense. Some people get all upset about that, but I like to think of them as documents that were printed in the wrong orientation, in landscape instead of portrait. And I have a lot of references and notes and things like that, and you can get the slides down there if you go to cote.io/unicorn coding. There'll be the URL at the end, but that way you can refer back to things, and you don't have to worry about taking pictures with your phone or whatever. So with that, I'll just briefly introduce myself. So this is me. I'm Michael Cote. I go by my last name. Right now, and hopefully for quite some time, I work in a technical marketing capacity at Pivotal. I basically do a lot of evangelism and what you might call enterprise architect and strategy advocacy. There's other people on my team who do more low-level things as far as operations and development, but I spend a lot of time doing this kind of thing and helping people out with strategy and doing podcasts and things like that, all of which you can find down there as well. And I'm always really interested in the feedback people have on this. It really helps me perfect the message and kind of study things better. So I'd be happy if you reached out through me through Twitter or email or wherever. And as far as the background, I've been an industry analyst for quite some time, both at Red Monk, a small firm, for about 6 years, and I also was most recently at 451 Research, heading up infrastructure software, the team that does that. And I worked at Dell doing corporate strategy and M&A for starting up the software group, and then doing cloud strategy, and then working on software strategy. So, before that, for about 10 years, I was a software developer at all sorts of places in Austin. But this background gives me as a real interest in improving the way that software is done. And I really, that's kind of been the obsession and hobby and now career that I have, is studying and looking at how organizations are successful and fail at software and how we can improve it overall. So let's start off with, this sort of iconic, funny picture, right? Like, if you're like me, a lot of what you read about, pretty much everything that you read about, unless you read the really boring books out there, are about these characters, right? These mythical creatures, these unicorns, as people like to think of them. They're fire-breathing unicorns with cats riding them and golden guns, right? And they do lots of wonderful things, and they go by names like FANG for Facebook, Amazon, Netflix, and Google. And every time you kind of read about what they're doing and try to get tips from them, it usually comes off, if you're like me, as seeming like, yeah, that doesn't really apply to me. That's great for them, but we can't do that here. And indeed, what I find is that most people in the real world, in the mainstream world, have this mentality, right? They're very much so Eeyores. Whenever presented with an optimistic idea or something new that they could be doing, they basically are really good at telling you all the reasons it could never happen at their shop. There's typically always some other person or department who's preventing you from doing something, or you've got regulations holding you back, or you have this pile of legacy software that's preventing you from doing something. But I find not all of them, but this is the main thing that we have to get over if we're thinking about improving the way we're doing software, is we got to figure out how to make these Eeyores happy. And it's definitely, worth it to do it. Like, it's not very nice being like an Eeyore all the time. It'd be better to be closer to Tigger or maybe even Pooh, who seems like a little happy. Now, all that optimism said, it is pretty valid to think of in aggregate. I'm sure everyone here is fine, and you're probably in the top quartile or whatever percentage of people who are awesome at what they're doing. But when you go talk with your peers who don't work with you, they may find themselves in this situation that we see represented by this great study from Cutter. And if you look at this, I've highlighted the part that I think is relevant. If you look at the role of IT in helping businesses innovate and, organizations or whatever, how useful is IT? Like, it's one thing to keep the email up and running and the calendaring and make sure you don't get hacked, keeping the lights on, the utility that IT does. But how good is IT doing at helping businesses innovate and do new things? And you can see that it pretty much embarrassingly was at 50%, right? Like, it's like that old thing about advertising spend. I don't know which 50% is successful. Like, only 50% of my spend is successful. I just don't know which. And that's where IT, at least in this survey, started back in 2013. And then it dropped to about a third of IT being useful, which is very embarrassing, right? And, there's this great study you can look up below from Meritok and Accenture. Any study that's sponsored by a vendor, you have to be a little suspicious of, but it seems to check out if you go look at it. It's actually got some great figures in there. And, I see this when I talk with government folks, that they are very much so in this, usually not in the good part of the little sad cloud guy there, right? Like, they want to improve, and there are lots of imperatives for them to do so. But they're not getting to that point where they have one of these checkpoints here is the ability to deploy quickly, right? As we'll see, speed is a key thing of importance nowadays in coding like a unicorn, if you will. So why is the reason that like a third of IT is useful, essentially? Or put another way, 2/3 of IT is not really helping their organization out. I think a lot of it is because we have this situation of the IT department of slow and no, right? Like, and it's not really IT's fault. They were set up to guarantee that things will work, to deliver on perfection and have uptime, right? And if you do that, if you think about it, the best way to guarantee performance is to do as little as possible, right? So you end up with these slow release cycles. You're always double, triple, quadruple checking that people actually know what they want. You end up doing a lot of finger pointing, and then you also end up treating IT as a cost center. Like, IT finds itself as not really being a source of inspiration, if you will, for doing things in a new way. It's kind of a hassle. It's a cost center. But what I want to go over and suggest is that you can do, maybe you can't transform into a unicorn. Maybe that's not possible for you. And it's also good with the metaphor to keep in mind that unicorns are mythical creatures. So I don't think they really exist. They're just a good piece of folklore to be instructive and teach us about things. But you can be sort of like one of these donkey characters. Like, donkeys are great animals. Like, it sounds insulting, but like, donkeys are hardworking. They get their job done. They're very, very healthy, like, good animals, and they tend to be, I don't know if I would call them cheery, but they certainly seem happy with their existence. They're just sitting there hanging out, chewing stuff. So you want to be one of these donkeys, and what you can aspire to is finding a carrot and very solidly sticking it on your head, right? This is I think what's very possible, and as we'll get to at the end, what I'm seeing people do is transform themselves into a hardworking beast of burden that acts like a unicorn. So there's two sections that I want to go over, and kind of going over the best practices and what's going on out there. And what I'll be doing as I'm going over this is I'm trying to distill down into a very short talk the top things that I would recommend people know about and look further into. I won't be able to like detail out very much of them, but at least it hopefully gives you a reading list, hence the dense slides and references. The first part is looking at the practices and the tools, the things that people like to focus on in IT, right? And so we'll look at this notion of getting beyond Agile, how Agile has evolved since it was kind of codified in 99 and then in 2001, and how the ideas of lean and DevOps have really come in and advanced what we think of as Agile along. Next, we'll look at how automating all the things, that is taking a cloud approach to stuff and doing continuous delivery, really delivers on and enables a lot of that, the beyond agile mindset that we have. And then finally, we'll get to the part that a lot of people get interested in, and I spend the least amount of time nowadays talking about, which is the actual programming work of how you architect things, the languages that you use, the style of development, and what the programming looks like. And as we'll find out when we get to the second part, the actual technical work, the programming, is usually the least of the concerns that you have. It's how you manage and organize everything around the actual work that you have that allows you to transform how you're doing and transform the donkey into the sort of like sort of pseudo unicorn, if you will. And when we go over that, I'm going to talk about how if you really want to do this in a large scale, it requires tops-down change management, and give some orientation about how managers and above need to think about that to enable the transformation to occur. And because of most the size of organizations I talk to, they usually have legacy as a chief concern that they have. So that's one item I'm going to pull from a larger study I have about transforming to highlight here. And then I'll close out by going over some examples of government and also other large and often regulated organizations as proof points that these things are possible, that you can stick that carrot on your head and start to code like a unicorn. So first, let's go over the best practices. And I call this section Beyond Agile. I mean, you could call it the evolution of Agile, whatever, but think about it as the methodology or the process or how you think about how you're doing software. And as we go through these things, compare this to how you're currently doing software and ask yourself if you know about these concepts. And if you don't, if you're not following these practices and you don't know about these concepts, then this is a good sort of list of things to go look up to at least understand what the best practices are and what's going on out there. So first of all, I would put the sort of birth of Agile, the beginning of the Rise of Agile, about 17 years ago. Now, of course, it started earlier than that in like the C2 wiki and, pockets here and there. And you can always go back to like the spiral methodology, and you can really do a whole bunch of like how many, Scrum Masters fit on the head of a pin type of analysis, if that's your thing. But in 1999, Kent Beck published Extreme Programming. Not pictured here, which was this like crazy book. Like you would read it and it was pair programming. You were like shipping every week. You actually had customers on the team talking with you or stakeholders. Like I remember pretty vividly the first time I was introduced to that book and the week that I was reading it, and it seemed awesome and scary at the same time. But that then, after that came Scrum, which has pretty much become one of the more popular ways of doing things over time. And now ideas of lean and also DevOps have entered into the system, and there's such a conflagration of people arguing about what is agile and what's not, that it's reached that stage where once you have all the sort of priests arguing about the different cants and everything, like that a level of comicness means that it's arrived and been mainstream. Now that said, if you look at this survey and just anecdotally and other things, this is from a recent Gartner study that they went over at their AADI summit back in Las Vegas. That's a great conference to check out. You see that our assumptions that Agile is mainstream are not necessarily validated by the data, right? They're definitely in use. So the way to read this chart is basically to add up the blue and the green. And that's kind of like that many people are doing these different Agile practices. And if you look through these, most all of these are traditional Agile practices, except maybe DevOps, which is relatively new, but and a little bit of behavior-driven development that's been around for a while, but it's not canonical all the time. But you see that they're actually, in aggregate, we're not doing Agile across the board, right? So what I would do is look at this and see where you fall in this, if you have plans for it or not. And it helps you benchmark yourself where you are, which can either be an excuse not to improve, or it can be motivation to improve as well. And also, if you're not familiar with what these practices are, this is a great list of very common Agile practices, and there's all sorts of books you can read up about. But what we need to realize is that we can do a lot better when it comes to applying Agile and thinking about our process and methodology, right? Chances are you're not in the category of doing things to the full orthodoxy way of doing it, and therefore you're not getting the advantage of doing things in an Agile way. Now, why does this kind of come about, right? Like, it's easy to decide to do a practice, right? It's hard to actually like do it and put it into practice. And all those things that I went over are not really that difficult to do, right? And the technologies usually are not the issue. And it really is the way that I think about this. If you look at this study from IDC about why projects fail, you notice that technology is not the issue, right? It's not the hardware, the software. As I like to always think about it, it's the meatware. It's the people that are failing at doing things. And this is why, as I was joking earlier, I don't spend a lot of time focusing on technology because I think that's the least of your worries. But if you look at how these unicorns, so to speak, are doing things, they spend a lot of time on process and how they orient things and how they manage the production of software. They think about it end to end, and they don't just focus on tools and technology or development or any given role. They're focused on the full end-to-end picture, and they spend a lot of time thinking about their process. So the takeaway there is that we think about software in the mainstream wrong, basically, right? Like we tend to, as kind of characterized here, we think about it as building a bridge or building a building. We're going to plan it out and specify the crap out of it, and we're just going to execute to plan, and after 12 or 24 months, everything's going to be fine. Like, we think that software is more like a hardware type of thing. But indeed, if you think about the fundamental nature of software, and this is why Agile is such a powerful way to think and why it's good to make sure you're thinking in an Agile way, software is incredibly malleable. You're only limited by the time it takes you to think of something, code it, compile it, hopefully test it, and then deploy it, right? And then actually run it. And then you can make the software do anything you want. Like, it's very malleable. You can this can be dangerous. You can whipsaw around and everything. But you want to think about how you can harness that flexibility of software. And, having a giant requirements document, a giant spec that you have to code to, immediately cuts you off at the knees as far as the flexibility that software gives you. But what we see with these, unicorns, for lack of a better phrase, is they take full advantage of that. Every day they can deploy software, or, multiple times a day, sometimes a week if they want to relax, right? But they use this in a very interesting application of the scientific method. And it's more commonly thought of as the lean startup approach. And I think of it as kind of like a hypothesis-driven development. And that is, they look at software as their laboratory for solving a problem. And the way they implement the software and do it, they're constantly making a hypothesis. If I put this button up in the right-hand corner, does that speed up how long it takes to do expenses? Or if I load up all these documents in a document workflow approval, does it speed things up and cause less errors to occur? So you have this hypothesis, but until you actually test it out with real users in production, you're going to go nowhere, right? You're not going to know if it's going to work. So you come up with a hypothesis, you code it, you put it into production, and you follow this. You don't do all your hypotheses at once. You try to focus on one at a time or just a cluster of them. And with the right kind of technology support, as we'll get into, you can actually get to this point where you're deploying weekly, if not daily, and you're running these tests. Now, what's important is to pay attention. And when you run an experiment, you need to run it and collect the data, analyze it, and then run the cycle again, right? So did it improve the accuracy and the speed of working on a case if you brought this relevant data in there? If yes, then do more of that. If no, then don't do that and come up with a new hypothesis and continually evolve it. And you'll hear me refer to this as a small batch way of thinking about things, right? We're doing small amounts of software driven by a hypothesis, and we're analyzing what comes out the other end. And this improves the quality of the software that we're doing. And this is really one of the core secrets of the sort of unicorn approach to things, is they're always studying and learning, and they make sure that they have an approach and a technology in place that supports that. And we'll get a little bit more into that in the technology part. But the other part that I think is really important to start to study, and this is a very hard topic to get into, and I have the most recent book that I think is a pretty good summary of it. But even that book, you have to slog through a lot of what seems like just advice about how to be a good person and how to relate to people and how to work with people. But the fundamental premise of this Effective DevOps book, and a lot of what you see in DevOps, is that software is a human creation created by groups of people. So we need to optimize how those groups of people work together. And then there's a bunch of technology as well. So you'll see a lot of focus on that, and it can get annoying after a while, but it's worth going through. But DevOps is this idea. It's pretty much exactly what it sounds like, aside from the culture stuff I was just getting over, is that if we're deploying software weekly, if not daily, there are different demands about the uptime and resiliency of it, right? And operations people are going to need to be a lot closer to the application and work with developers, and vice versa. Developers are going to need to write their software to fit into this mentality of working daily, if not weekly. And we'll get a little bit into how some of the details of how that pans out there. But what becomes apparent, especially if you take a lean approach to things where you're trying to remove waste, is that if we separate out development and operations, the sheer handoff between the two of them and communication is waste in the system. It doesn't value anyone. There's no reason to have those silos. You might think that you're optimizing, the ROI, not even ROI, but you're optimizing the time of these people by wrapping service desks around them and process. But in fact, you're just adding extra time and the chance for error when things pass off between there. There's no value to the end stakeholders you're delivering to. And so over the past, I would say 5 to 6 years or so, like it kind of started quite some time in 06 and 07, but there's been a great body of practice known as DevOps about literally, and it actually means this, putting these people together, developers and operations, on the same team, and all of them having full end-to-end responsibility from the application, ops all the way back to development, and development all the way through to production. And also, in general Agile think nowadays, you might even have the idea of integrated teams where all the roles you need to be successful in software are on that team. And, if you go look up a lot of what 18F and others in the federal government are documenting as they're getting better and better at Agile, you see them emphasize this integrity of the team and having all the roles you need. Because, again, you're applying lean to it and removing as much waste as possible. Now, there's a lot more to look through in DevOps. I would recommend, if you want a really short read, there's chapter 8 that I referenced down there in the practice of cloud system administration, and that is actually a pretty phenomenal, concise description of what's going on in DevOps. And I haven't finished Effective DevOps yet, but it looks like it's a great book. I've got a Safari subscription, so I can read the early release of it. And there's some other references down there as well. If you want, the Phoenix Project is actually a pretty great book. If you're in IT, I mean, it's a fictional account of an IT department, so you've got to be pretty nerdy to enjoy it. But it'll give you a good sense and maybe a little bit of PTSD when you read through it of what DevOps is and why you would think about it. And then also that what is DevOps post is pretty good as well. So let's get into the idea of automating all the things, right? Which is largely about technology, but is also a process way of thinking. Now, when we think about automation, if you're like me and have been around for a while, and I'm pretending I'm looking out at the room, and there's probably a bunch of old farts like me. Like if you're like me, and it looks like most people here in the room are, you probably think of this. You probably even know what Rube Goldbergian things are. But automation has always been the point of computers, and we always kind of end up with this, right? Sort of gratuitous automation, like you could just pick up that napkin and wipe your mustache after getting some soup, but instead you've got this crazy contraption that's going to end up taking way more effort than the original effort you were saving, sort of locally optimizing, if you will. But, it's nice to have an excuse to use that funny image. But this is actually quite an old diagram, if you see, from 2007, and it's still incredibly useful because I don't think the practices that achieve this secret sauceness are as widespread as they can be. This is one of the core differentiators that these unicorn companies, the FANGs and everyone, have out there, is they completely, not completely, but they very much so decimate. I guess that would be only reducing by 10%, but whatever. They really reduce down the amount of time, effort, and resources, that is, attention, time, and money spent on operations, because they've automated so much, right? They spend so much of their time only worried about the core business logic. And, this chart illustrates that idea, how dramatically you can reduce things. This is from the era of Chef and Puppet and things like that. In fact, it was done by the then CEO of Chef, if I remember my ops code history correct. But it really illustrates how dramatic of an improvement you can get. And essentially, I would say if you're spending a lot of time on configuration management and even monitoring and operations, again, you're probably not doing it as well as you can. There's a lot of benefit with automation that you can get. So, and that's a large part of what cloud gets you. Now, once you have all this automation, one of the key parts of automation for software development and delivery is getting a continuous delivery pipeline in place. Now, this includes continuous integration, right? Which is the idea that a developer codes something, they check it in, and then another automated system checks everything in and automatically runs the tests and see if when it integrates together, everything works. This is a big time saver, something that if you're not doing that by now, then that's sort of step one. You should really get to that. But you also have a complete pipeline set up so that theoretically, if you wanted to, a developer could check in a line or lines of code. It would do a continuous integration build. If everything checked out, if it was green, it could automatically deploy it to production for you. Now, you might choose to deploy it to only like 10% of production and see if it works or not, and then deploy it to 20% of production and redirecting traffic and things like that with your blue-green deploys and canary deploys and things like that. But you can deploy things automatically. And because you have such automation and testing, and because you're focusing on a small batch approach of just doing a small amount of things each time, and because you also have the power to roll back changes because you're using the right kind of cloud platforms and technologies, you kind of get in this cycle where you really can deploy automatically. Now, there's all sorts of regulatory stuff where you might need to have a separation of concerns and have someone else do it. But, at most you're talking about adding a day or so. We'll get to 18F thing where they've gotten their ATO down to 3 days to deploy something, which is phenomenal compared to how long it usually takes. And then that allows you to get into this hypothesis-driven way of doing small batch development where you can deploy stuff constantly to production and observe the feedback and improve the product. So this just gives you way too much detail of an example of what it actually looks like, right? So you see a developer commit something, tests go through, and it kind of gives you an illustration using open source Cloud Foundry, what it looks like to do that. But all of this stuff is automated for you, and it really is a phenomenal way of going about doing things. And it gets you into that mentality where you can start improving your software. I want to go back here because I think what's one thing that's very relevant to this audience is that when you think about auditors, right? Usually the first thing that we hear when we present this is like, oh my God, developers are going to be deploying to production. The auditors are going to freak out and it's not compliant. But when you go and study a lot of regulation, whether it's self-imposed or external, a lot of it is about ensuring that you have the right controls in place and that a lot of smart things are done, right? Like you should run antivirus on your laptop and you should encrypt connections. I'm thinking of like PCI compliance is one thing. But usually when you expose auditors to this kind of stuff, they love it because it's a lot more reliable, it's consistent, everything's logged, and the more automation you have, it actually fits pretty well with what you see people wanting for a compliant sort of way, as we'll get to towards the end as well. But just set that aside for the moment. That actually fully gets addressed. We're not talking about developers willy-nilly deploying to production unless that's what you want. So let's look at programming, and then we'll get into the transformation part of it. So this is how the actual work of what we think software development is chiefly comprised of, how that's been changing. So I think this is a wonderful kind of quick summary I got from, if you have the chance to read that Forrester report down there, there's 2 Forrester reports that this guy, Randy Heffner, has been involved in, I reference in here, and they're like phenomenal. They're great reads for understanding what's going on in this space. I used to be an analyst myself, and it's rare to encounter something that practical. But you can see kind of the evolution of software all the way up now to today, where we have all sorts of languages that we're using. You have a microservices-based approach, which we'll go into a little bit. And there's more of a focus on as small as parts as possible, right? Again, small batches, small things that are loosely coupled rather than large monolithic things, right? And with the introduction of like having a supercomputer in your pocket all the time, being always on mobile, right? Like that drives a lot of this attention here and a lot of the interest in things being different. But it's pretty understood that this is the gradient of how things have been evolving, and there's more of an emphasis on using the right tool for the right possible for the right problem, and really focusing on a loosely coupled architecture for things. That's the as Forrester goes over here, that's the state of the art at the moment. So to that end, this is actually the firm I used to work at. Long after I left there in 2011, they came up with this great, I think they do it every quarter, programming index. And they have a pretty good methodology where they go out and scan Hacker News and Stack Exchange and GitHub and all sorts of data sets to come up with this. But what's interesting to note are what the top languages are. And, if you could watch this over time, I think they're doing one of these where you can see it shifting around. You can see languages coming and going. But these, more so than thinking about what the top ranked languages are, what you notice is that developers use multiple languages, right? They have this polyglot approach where they're not only Java developers, they're probably at least also a JavaScript developer. They might use Go at the system level. You can see that at place 15. And obviously in the mobile space, you see a huge amount of Swift usage if you're supporting iOS. I mean, that's the fact that it's risen up to number 17 is phenomenal for how new that language is. But you should be familiar with different languages, and you don't necessarily have to master them, but it's good to monitor and allow yourself the ability to use a language that fits exactly well with what you want to do. It's not really the case like it was in the Java.net days or even before that, where we were basically a Microsoft developer or a Java developer or those rascally LAMP people, and that was all that you did. The advantages that unicorn companies get nowadays, their ability to have good software and services, comes from taking advantage of being able to use whatever language fits well and having the approach and technology that supports them. So let's get into microservices a little bit, and then also 12-factor application development. These are the things that we start at the architectural level and get down to the way that you think about designing and developing your software. Now, I'm always lacking for a good way of illustrating microservices, and it's probably best to think about it in contrast to WS star, web services driven SOA. So a lot of the goals and benefits that you have with the microservices approach are the same that you had with SOA approaches, right? You want to have pretty well-defined and I guess you could say decoupled is the wrong word, but consistent and self-contained services, right? So here's a service for for users. Here's a service for inventory that I have. Here's a service for currently open cases that I have to deal with in my service center or whatever. But the difference is that, this is just my sort of take on it, is in the SOA world, we sort of ditched, if you will. We got really distracted about data formatting and interchange and compatibility and also don't repeat yourself and reuse. And we ended up way back where we started with these gigantic monolithic sort of usually ESB-driven things, but also just sort of architected by committee, great sort of like cathedrals of things. And that worked out for a while. But then the issue that you get is it's very hard to change. You can't operate at that small batch mentality of speed, so you lose the key enabler of speed that you get. And also in a polyglot world, it typically means that you're restricted to one type of language. That doesn't have to be the case, but what ended up panning out is when you're doing first generation SOA approaches is they would all be in Java or all be in .NET, like all of these sorts of things. The sort of being able to use different languages didn't seem to pan out so well. So a microservices approach, it starts to come from this need of we want our architecture, the way we separate out our services, to be as nimble as possible. We want to make it so that if we wanted to, we could update those services out of step, right? Like we don't need to wait to update here's the open case stuff on there's no dependencies over to like the user management system. And so what microservices is, and this is something you should look a lot more into, and we have some good, we sponsored some books you can go read up about this for free. Or there's other resources. But there's two things I would say you emphasize is you want to decouple your services so there's no dependencies between them, so they're more resilient in being smaller and independent, and they can be on their own release cycle. And you also take advantage of Conway's law. So Conway's law is basically, there's like 4 of them actually, but the one that everyone pays attention to is that the architecture of an application is going to end up mirroring the organization communication path, basically the structure of the organization. So if that's always the case, then why don't we structure our organization to model the application that we want? So you end up having teams that own each of the services that you have, each of the functions in your application, and then you kind of take advantage of this, right? If they're completely self-contained, they're decoupled, they're on their own release cycle. You find, and definitely unicorn people who follow this find that they can start developing and doing things a lot more. And also because they're independent services and there's smaller batches of them, there's more resilience to them. If, this introduces some problems, immediately what you should be thinking is like, well, what if they make a change over here and that's incompatible over here? So like the old joke about the doctor, says, don't do that. Maybe you should not do that. You want to have a good way of managing the APIs that you have and having backwards compatibility, and you set up a policy with that. Java was always very good at this. It would get over those things as much as possible. And then also, the platform that you run all of this on, you want it to build in a lot of things for handling, like if the service goes down, you want to continually monitor the service. You want to build in authentication and all sorts of things wrapped around that. Again, just like what a lot of SOA stuff was doing, is it was seeking to solve those common problems for you. But the difference so far in the microservices approach is that they care a lot more about maintaining the independence of these services. They're not very much focused on data interchange or compatibility or even don't repeat yourself principles. They're solely focused on having decoupled services that allow you to operate quickly, which I think will end up in a different result than we had in the first go at SOA. So if you want all those benefits of speed and decoupledness, if that's a word, then it really is worth figuring out how you solve those problems. And there's a lot of different frameworks and approaches out there that help you solve the problems. So next, when you start thinking about how unicorns code, they tend to, they don't always do this, but this is a good place to start, is looking at what a 12-factor app is. And this is something that I forget when it was, but Heroku, if you know them, they came out with this a while ago, and it was kind of like some guerrilla marketing on their part. And it basically defined the way you need to do your software if you want it to run on Heroku successfully, right? And so if you kind of read through these, just to highlight one, like one of them is like, do everything over HTTP as much as possible. There are queues that you can use, but follow a web networking architecture. And also, like, as another interesting one, like, don't use local storage. You should always use a backing service. And the way that's configured, if you're familiar with the way dependency injection and stuff in Spring, it's kind of similar to this idea of use the passive voice, so to speak, and having services hooked up to you and configured. And what this does is this creates a very stateless type of architecture. I mean, the annoying secret of 12-factor stuff is someone's got to worry about state. You do need to have a data service, a database up somewhere, and that's still a problem. But you remove as much state from the system as possible, and it gives you what we're kind of calling nowadays a cloud-native approach to doing things. It allows it to run on a platform as a service or a cloud or container-driven platform for doing things. So basically, if you're not familiar with these, it's good to read up on these. I go and read them all the time, and I get more confused as I read them, which is, that's the effect of great poetry, I guess. But this is it kind of gives you principles and guidelines for how you start doing development, like a unicorn, and how you think about arranging things and stuff like that, and start thinking about how your runtimes and the platforms you're running this in and the way you do things support these ways of doing things. And there's actually also a lot of interesting input about how you arrange your project and work with your version control, and there's some DevOps principles that pop up here as well. So to round out the technical part, there's a great piece from Brian Gracely, analyst at Wikibon, going over this idea of a structured platform or a cloud platform. And these, you always have some runtime that your software is running in, whether it's way back when a mainframe with all the services and ways of deploying and monitoring in it, or an app server is another platform that you have. The LAMP stack is a platform, and nowadays people have spent a lot of time building their own platforms, on Docker and containers and things like that. But there are actually, if you go read his piece, you can see a full vendor landscape of open source and commercially available things. There's a lot. Cloud Foundry is one of those things, and we have a distribution of it, hence my interest in it. But there's a lot of platforms out there that are built to support all the stuff I just talked about. They support a microservices-based approach of things. They support 12-factor apps. And their goal is to make a small batch approach possible and successful. And this is a lot of where the automation actually works and what's net new from last time. And as we'll get into at the end, there are actual people who are using this and it's successful. It's not just a bunch of hokum and snake oil. But kind of look up that piece. And there's another piece that a coworker on my team wrote for O'Reilly Radar that kind of goes over what these platforms are, what capabilities and requirements you need for them. And it helps you think about the runtime layer in the platform that you need to support that. But I would stress that if you're in software development and people are talking to you about cloud, this is probably what you end up thinking about. This is what your cloud strategy will be about, is getting this in place and then following that small batches approach to doing your software development. So let's wrap up by looking at what it means to transform and some tips about transforming, right? Because you can install all this technology and that's all fine and dandy, but you need to change how you operate, right? Like how you run and manage things. I often think, like, people talk about transformation and it's like this great scene from a movie. Hopefully many of you have seen. You'll never guess what happens next with that guy. So basically, there's a whole lot we could say on this topic, and these are two great books on it, especially Leading the Transformation. That's any objection you have about doing all this funky unicorn agile stuff is kind of addressed in that book, and also by the nature of the type of projects and use cases that it drives from. But I would check that out. But the main thing to think about is that if you want to do transformation at a large scale, it needs to be done in a tops-down fashion, right? Like I'm at pains to think of a consistent way of having a bottoms-up way of doing transformation. So the first thing that you'll need to do, if you're in management or you have some influence on management, is get them to shift their way of thinking over to their new job is managing change management, not managing keeping the lights on or managing sort of like process or things like that. because there's a lot of changes that will be going on about how you develop your software and do things. And indeed, we see this in those kind of unicorn organizations. So they need to understand their organization, how it works, and plan out the gradual organization change. Another thing that becomes key, if you think about being a good human as kind of like a basis of DevOps talk, is over communicating, and this is emphasized great in leading the transformation, always communicating what the goals are, what the strategy is, why we're doing all of these things. And another topic that I think is important, because it's a little counterintuitive, is you want to start as small as possible. So once you understand how to do things all of this way and you get the things in place, pick a small project. Pick something that is important and has users so that you can deploy it to production and observe it, but don't start with the biggest thing that you have or the most problematic thing. Start with something small and learn through it, right? Like a lot of what you're going to be doing is figuring out how you convert failure into learning. And what that means is that if you remember that dog way back when, like whenever you're doing software like this, you don't really know what it is the end result should be. And as we all know, anyone who gives you a big stack of documents, they usually have no idea what they want as well. And even if they know what they want at the moment, they want to get exposed to like new things that might come to light and new ways of doing things that could be helpful. And so we want to take advantage of that fungible nature of software. And the way you learn is by failing, right? Like my kid's in kindergarten now, and he's constantly failing at stuff. He gets frustrated at it. But like over the course of like less than a year, he's learned how to read, and he's learned how to do subtraction and even like basic algebra, which is like amazing. I think in kindergarten, I was like lucky if I was eating glue and stuff like that. But like he had to fail a tremendous amount, and he's got like, I don't know, many couple decades more of failure ahead of him, but he's going to learn. And so management is the one who has to put this in place and start rewarding learning instead of punishing failure, which is a huge mental shift to go through. And like I said, I mean, I would definitely check out these two books as a way of thinking about how management can do better at Agile and help the process out. So next, I'll reference a booklet I have that goes over a lot more things about transforming at the end. But legacy is another blocker that comes up all the time. And there's really no easy answers for it. There's just the obvious answers that no one does. So there's kind of this sieve that I would go through, or a sluice, if you will. And that is, look at your giant portfolio, right? So, in my mind, legacy is the stuff that makes all the money, all your existing IT that you kind of sort of don't want to touch. And figure out, basically dealing with legacy is all about figuring out what not to do and what not to do with. Quarantining applications and being very active about your portfolio management. So don't worry about low impact applications. You're going to waste your time with that. If you don't have good testing, it's very risky to change, and you may be forced to deal with stuff where you don't have good testing. But that's another danger sign of something that is kind of, you probably shouldn't touch. And if there's all sorts of priorities like industry compliance and all sorts of dependencies and couplings that makes it resistant to change, that's also another thing that you probably don't want to take this new approach to doing things with. So you sleuth those out. Now, you'll still be left with a lot of things. So the first thing you want to do is, if you haven't virtualized a lot of the applications that you have, that will if you remember all operation and automation things, that'll take a tremendous amount of waste out of your system. So you should make sure that you've done that. Next, if you can't rewrite or refactor the applications that you have, you can follow what's known as a strangler pattern, which is basically, you can think of it as like a facade or a proxy, to use old Gang of Four mentality. But you systematically wrap new interfaces around things, and you buy yourself the time to change the back end without the client knowing that these things are being changed. The dream of OO, that you can have an interface and change the implementation. But the strangler pattern, if you go look it up, it's named after the plant, not like a psychopath, is a pretty well-trod way of going about this. And then finally, ask yourself and your managers, do we do portfolio management? Every 12 months, if not every 6 months, do we sit down and look at all of the applications and do at least a BCG style matrix, where we think about a matrix of value versus however you rate value versus effort we're putting into it, and figure out ones we should retire or spend more on. What are the dogs and the heroes? Like, I find that most people don't do portfolio management in a very rigorous way, but it becomes incredibly important for large organizations. So finally, let me wrap up with a few cases, right? Because I think when I and people in my line of work go over this, it can seem a lot like this drawing, right? Like I remember these ads from the 80s, right? Like, hey, drawing's really easy. Like, you just draw some circles and then bam, draw the rest of the owl. And I'm pretty sure there's a lot of steps in between 1 and 2. And This is why I think listening to purely unicorns is not useful, because they don't know how to do things between 1 and 2. They don't really even know how to explain it or go over it, which is very frustrating. But I want to assure you that it's a lot more like our old friend Bob Ross here, right? Like, again, it looks like most people in this room have been exposed to things in past decades like I have, but you would watch him start with a blank canvas and seemingly just like, you would witness him make these awesome landscapes, and he was so friendly, right? Like, he was actually showing you the complete end-to-end process of doing things. And I want to assure you that things are a lot more Bob Rossy if you just know the right hairstyle to have if you want to act and code like a unicorn. So first of all, to further drive this point home, it's easy to go to like the unicorns, right? And this quote was in Twitter, so it must have actually happened. You can look it up there, and I think it illustrates a principle that my boss Andrew Schaefer, he did a talk on way back when. It's a great talk to go look at. Is that you have the people and the resources to do this, right? You're just not thinking about and training and deploying them well. And hopefully I've gone over a lot of ways of reorienting how you think about software and technologies you can use. That was the point of everything I talked about here, is think about if you're doing those things and if you know what they were, and you just reorient to doing that stuff. And it's not hard. It's hard to make yourself do it. And to that end, and this is true, like as Adrian Cockcroft said, right? Like, we didn't like grow these people in a vat who do all this stuff for Netflix for us. We hired them from you, right? You had them the whole time. We just knew how to like nurture them and grow them and make them successful. So the first case to go over that's highly relevant is if you go look at 18F, and I think they've spoken with you guys or will soon, but they're a phenomenal reference for doing things in this way. They run gov.cloud, and they do two things that fit really well with everything we've talked about. One, they follow a very sort of agile approach of doing things, beyond agile, if you will. And they document it really well. Like, part of their mission, and this is why I spend so much time talking with government people, is this sense of mission that they have to do things instead of just focusing on profit. So part of their mission is they document how it's doing, and they try to help other people out. So they've got a lot of docs and a lot of help that they have. But they also have some good cases of applications that they're running in this way on a cloud platform, focusing on small batches, the whole 9 yards. They've gotten to this point where they can actually deploy, they can get through their authorization to operate in a matter of days, when it used to take like 9 months or even more. I always throw 9 months in because a year just sounds too crazy, but maybe it did take that long. And the way they did this is they worked with the auditors and the compliance people, and everyone understood this new way they were going about doing things, so that they didn't have to revalidate everything every time they wanted to deploy, and they just had to look at the actual code that was changing. And because they were following all this disciplined approach and using a cloud platform and everything, they got to this point where they could do this. And they're having phenomenal success with this approach, changing those Eeyores over to donkeys with carrots on their head. And next, this is a quote from a good ETrade story that hits on the regulation thing, right? So ETrade, everyone knows what ETrade does. It's sort of a retail brokerage firm. So they're very highly regulated, right? Anything having to do with money and buying and selling stuff is regulated. And this illustrates what I see a lot, is that actually, once you get these practices into place, you're doing things this new way. Auditors tend to love it, and they wonder why you weren't doing things like that in the past. If you go read the Phoenix Project, you'll see this. You'll read a narrative of this transformation taking place with a security person. But think about all the controls and automation that you have, and all the visibility that you get with the small batch approach, right? Like, pretty much everything is visible every step of the way, and logged and audited, and it's consistent, right? You follow a consistent practice. And these are the kinds of things that make auditors really happy, right? They want to know that you're doing the right thing. They don't care if you're successful or not, but they want to know that you're doing things per plan and you're not being malicious and following things. And they tend to really glom onto this. And you can go look up that reference and read a little bit more about ETrade's journey doing all of this. So these are anonymized from some Forrester reports. And there's some more use cases you can look up, again, from Brian Gracely, where he kind of walks through several cases of organizations applying all of this type of think, this cloud native think, if you will. But I really, the one that I like the most is the one on the left there, right? Where we're at a large financial institute, and remember the reverse Anna Karenina policy is like, they pretty much have most of the same problems that you have and vice versa, right? Every large organization has the same type of issues to work through. But they found that when they took this small batch approach, right, they had projects that needed to be delivered on a quarter or less, they would succeed 80% of the time, and they got the opposite result, failure 80% of the time on things that were delivered on a year. Now, again, I'm sure everyone here, no one has this problem. You probably can work on a project for 3 years and it's completely successful that day that it's deployed after 3 years. But I see this reflected everywhere, right? Like the longer it takes you to actually ship the product, deploy it into production, and have users using it, the higher the chance of failure. So you want to focus on more of a small batch mentality, which trickles down to everything and more that I've been talking about there. And the other anecdote is just a good one of I kind of emphasize the thought that everyone has in their head of like, why am I doing all this paperwork instead of actually shipping code? As a former coworker of mine used to say, I used to be good at my job, but now I'm just good at PowerPoint, which is pretty much my job at the moment. So with that, if you want to dive into this more, other than getting these slides and kind of looking at references or talking with me, again, you can reach me through Twitter or email me, whatever. I'm always delighted to talk about this stuff. I released a little booklet. It's 30 pages, if I remember. And it goes over a lot of these concepts and more. There's more issues here, and it divides it into 3 types of projects: greenfield, legacy, and overall transformation. But I made sure that we have lots of links in there to all of the types of references and the best knowledge. So to me, it's more of a bookshelf in the form of a PDF that you can go to like look about and learn about all of these different things there. And you can just get that if you go to cote.io/pivotal. You can get that, and I reference some books that we have available as well. They're O'Reilly booklets that go over microservices and also Cloud Foundry. You can get free copies of those as well, and find all the other kind of nonsense that I do in this area. So with that, right at 51 minutes, basically, not too shabby. With that, I always like to wrap up with this slide because it kind of brings me back to like what brought me to Pivotal and what I've been studying on since I accidentally got into programming way back in high school. Is I'm always very interested in figuring out how to improve software, right? Like we all use software every day, right? We have the effects of software. And another reason I always like talking with government people is I feel like, other than putting money in my pocket, if I'm working at a company and being profitable, that's a great way that improving software can help out if I'm involved in that loop. But if we can just have like single digit, if not low double digit improvement in the software that the government uses, the governments use everywhere from like, from MUDs to city to county to state to federal to other countries, like we can improve our daily lives so much, like because the government is everywhere and software is everywhere. And the more improved that we can make software and government, the better all of our lives will be, right? And that's ultimately, I think, what we want is just to have better lives, or at least not to have worse ones. And nowadays, a lot of what we see in the software world, it's all possible, right? Like it's possible to do anything you want with software if you have the right approach to it in place, thinking about its fungible nature and taking a small batch approach to always be learning and improving. And you're using the right practices and technologies that enable that kind of doing things with software. So with that, thanks again, and I'll be around for a while, and I'm happy to take any questions now with the time we have, or do anything else. Bye bye.